Hi all, today we will discuss reciprocity theorem. So it states that in a linear bilateral single source network, the ratio of response, that is the output, to the excitation, that is the input, remains the same even when the positions of response and excitation are interchanged. Let us understand this with the help of this circuit. There is a network. This consisting of resistor, capacitor, like that. Okay. So what is the value of I naught we are getting here because of this source Vi? Okay, because of this source Vi, and if we interchange, if we replace this Vi, if you replace this Vi to this response, and if you measure what is this response at this in here, that is the second circuit, they are same. Okay, that is what it states. Okay, if you interchange this, this is excitation, now this is response. Okay, response is the output, excitation is the input. If you interchange these two things, there is no change in, okay, there is no change in the response. If you increase, then the case is different. If you just interchange them, there is no change in the output. Okay, so let us verify that using this circuit. Okay, so here what is the excitation? 10 volts, right? This is your excitation. And what is the response? This current I. So can you calculate this I? You can apply any methods, you know, mesh, KVL, KCL, anything you want. Okay, so I have applied a nodal analysis for calculating this I. So they have given the direction for I in downward direction, so I assume that I1 is entering to this node Vn, and I is leaving this one, and I2 is also leaving. So applying KCL, what you will get? I1 is equals to I2 plus I, because I1 is entering, I2 and I are leaving. Okay, so what is I1? What is I1? This is I1, right? So 10 minus Vn divided by 20 is your I1. Okay, 10 minus, because current is flowing in this direction, right? So starting from leaving terminal 10 volts, 10 minus entering terminal is Vn. So 10 minus Vn divided by 20 is equals to I. So this is the starting terminal, right? So for current flow, okay, Vn minus, this is ground, so Vn minus 0 divided by 5, and I2 is what? Starting current, starting node is Vn, so Vn minus 0 divided by 30. So I hope this is clear. Now calculations for Vn. So I am dividing 5 on both sides, so we will get 10 minus Vn divided by 4. 20 by 5 is 4, 5 by 5 is 1, 30 by 5 is 6. Okay, and then just cross multiplication here, you will get Vn as 1.76 volts. Okay, 1.76 volts. So we know the value of Vn now. So what is the value of I? So I is Vn minus 0 divided by 5, right? So Vn we know, minus 0 is Vn only, divided by 5. So 1.76 divided by 5, that is the value of your current, 0.352 amps. So if you interchange them, excitation and the response, this value should also be same as this value. You can use any other method to calculate this I, so that those two things should be equal. Okay, this you can verify using piece-based simulation. Okay, I am not doing that because this is just simple circuit. You just have to write this circuit and verify what is the value of I in both the circuit. Okay, in both the circuit, what is the value of I? If you calculate, if they are matching, then this theorem holds good. Okay, thank you for listening.